All right, so we're looking at right triangles and the Pythagorean Theorem. We remember that a right triangle is a triangle that has a 90-degree angle in it. And whenever we have a right triangle, and we know two of the side lengths, so let's say we know this one and this one, we can use what we call the Pythagorean theorem to find the length of this one. And it always works with right triangles, but it also only works with right triangles. So if you have a different type of triangle, like an acute triangle or an obtuse triangle, you cannot use this to find a missing side. It only works with right triangles. So some vocabulary that we need for this when we get started are legs and hypotenuse. So the legs of a right triangle are the two sides that create the right angle. So it might not always be the two sides on the left and the bottom, but it's going to always be the two sides that create that right angle. And then the hypotenuse is the long side or the diagonal side, and that's the side that's not touching the right angle in any way. So if I had a right triangle like this, I would have a leg, and hypotenuse. Or if I had a right triangle like this, I would have a leg, and a hypotenuse. So the legs are always the ones that are making the right angle, and the hypotenuse is the one that's not touching the right angle. And when we're dealing with Pythagorean theorem, the legs are A and B, and the hypotenuse is C. So the Pythagorean theorem says that when we have a right triangle, A squared plus B squared equals C squared. So if we know two of these things, we can always find the third thing. So why is this even helpful? What is this useful for? Well, there are two things we use the Pythagorean theorem for. We use it to find the missing side of a right triangle, and we also use it to test if a triangle is or isn't a right triangle. All right, so let's give it some practice. We want to apply the Pythagorean theorem, which remember it says A squared plus B squared equals C squared, to find out if these triangles have a right angle or not. And so when I'm doing that, I kind of have to look at the triangle and say, okay, which one do I think looks like the right angle, whether it is a right angle or not. And I think that on triangle number 1, this looks like a right angle to me. So I'm gonna use these as my legs, and then this will be my hypotenuse. So I should be able to say 8 squared plus 6 squared equals 10 squared. Now 8 squared is 64, and 6 squared is 36, and 10 squared is 100. Is that true? 64 plus 36 equals 100? Yeah. So that means that this is a right triangle. Now if I look at this triangle number 2, I'm gonna guess that this looks like the right angle. These other two are definitely not right angles. So I'm gonna say this is my leg, and this is my hypotenuse. So I should be able to say 12 squared plus 10 squared equals 17 squared. Well, 12 squared is 144, and 10 squared is 100, and 17 squared is 289. 144 plus 100 is 244. 244 does not equal 289, which means this is not a right angle. Now I can also use the Pythagorean theorem to find a missing length. So these are telling me they already have their right angle drawn into them. So I know for a fact these are right triangles, which means I can use my Pythagorean theorem, a squared plus b squared equals c squared, to find the missing length. So in this triangle number 1, this is a leg, and this is a leg, and this is the hypotenuse. So I have 6 squared plus, I don't know what this is, so I'm going to keep it as b squared, equals 7.5 squared. And I know that 6 squared is 36 plus b squared equals 56.25. And now I need to use my tools for solving for a variable, where I want to get my numbers on one side of the equal sign and my variables on the other side. So in order to do that, I'm going to subtract 36 from both of these sides. And if I do that, I end up with b squared equals 20.25. And then remember, just like when we were finding the radius from a circle that we knew the area of, to get rid of this square here, I'm going to find the square root of both sides. And the square root of 20.25 is 4.5, which means the length of this line here is 4.5 yards. Pause this video and determine the missing lengths of the other 2 triangles. All right, so on this one, we know the 2 legs, we just don't know the hypotenuse. So we can say 4 squared plus 10 squared equals c squared. 4 squared is 16, and 10 squared is 100. So 116 equals c squared. And remember, in order to get rid of that squared, I'm going to take the square root of both sides. And I end up with a long decimal. But here it tells me to round to the nearest tenth, or 1 decimal place. So I have 10.8 inches. And on this last one, I have a leg, and I have the hypotenuse, but I'm missing another leg. So I have 18 squared plus b squared equals 27 squared. Now 18 squared is 324 plus b squared equals is 729. And I'm going to subtract 324 from both sides of the equal sign. And I get b squared equals 405. And then I take the square root of both of those sides. And again, I get a long decimal answer, but I'm rounding to 1 decimal place. So I have 20.1 feet. All right, so let's imagine that you have a 5-foot ladder, and it's leaning against a wall, and the bottom of the ladder is 2 feet away from the wall. So we know the ladder is 5 feet, and it's 2 feet away from the wall. The question is, how far up the wall will that ladder reach? And we can see that the wall makes a right angle. And so we know we have 1 leg, and we don't know this other leg, and we know the hypotenuse. So we can take 2 squared plus b squared equals 5 squared to tell us how far up the wall the ladder will reach. 2 squared is 4 plus b squared equals 5 squared is 25. We can subtract 4 from both sides of this, and we get b squared equals 21. And then we take the square root of both sides, and the square root of 21 is 4.58, and we'll leave it at 2 decimal places. So if you have a 5-foot ladder and you lean it up against a wall, and the bottom of your ladder is 2 feet away from the wall, your ladder will only reach 4.5 feet up the wall. Pause this video and give this one a try. All right, so when we measure televisions, they're actually measured diagonally. So if you're told that you get a 75-inch TV, it's actually 75 inches from one corner to the diagonal corner. So let's say you're buying a TV and you see a 75-inch TV, and you know that the height of the TV is 37 inches. How wide is the TV? So if the television is measured diagonally, we know that this is 75 inches. And then the height is 37 inches. How wide is this TV? So again, we know the hypotenuse, we know one leg, but we don't know this last leg. So we can say 37 squared plus b squared equals 75 squared. 37 squared is 1,369 plus b squared equals 75 squared is 5,625. And then we'll subtract 1,369 from both sides. Oops. And we get b squared equals 4,256. And then we'll take the square root of both of those, and we get that b equals 65.24. We'll round up. So if you have a 75-inch TV that's 37 inches tall, it will be just over 65 inches wide.